Welcome. In this video, we're going to talk about assignment 3.2, the Excel project for module 3. And let's look at the assignment itself first. It says, this assignment is about using the solver. So let's look at what it says here. Before using the solver, make a few changes to your log table. It says consider, so you don't have to. It says for each food item for which you have previously constructed the two variable data tables, add rows with portion names and calories per portion that correspond to the data tables and insert 0 in the portion amount column for these rows. That's a really convoluted sentence, and I'm going to suggest, since it says consider making a few changes, don't bother. I'm fine with that. But it does say make use of the sum product formula. So we're going to do that. And then we're going to use the solver. And if you don't know what these things mean, we will discuss them. All the portion amounts must be whole numbers, right? We don't want to see 1.5 portions or 1.75321 portions because it will give you things like that. Also, negative portion amounts don't make sense. For food items with alternative portion sizes, the approach is to reduce the portion sizes and adjust the portion amounts. Again, we're going to simplify this and just adjust the portion amounts. So, food items with no alternative portion sizes, either reducing the portion amounts or eliminating the food item from the log. But consider what happens on balancing your diet. So the target cell has to be non-negative. This is important. They suggest setting the maximum time option for the solver for 100 seconds. If everything has to be an integer and you have a lot of constraints, then it can take the solver a long time to find an optimal solution. So we're going to set we're going to give it a time limit and say, give us the best solution you found within 100 seconds. So let's look at what we've got. This is the food log from Module 1. The only thing I've done differently, when we did Module 1, I suggested that this number be a formula so that you could change the portion amounts and it would change this. Now we're going to use the sum product formula. Also, you'll notice I've got all of these set to 0 because we're going to let the solver figure out what they should be. But if I, for example, say 1 egg, the calories per portion doesn't change, right? It's always 43 calories per egg. So down here for the total per day, and I put in a goal of 3,000 calories. I'm a big guy. And right now the difference is 0 because the total per day is 0. I mean, the difference is negative 3,000, so I'm short. So how the total per day, how the sum product formula works, type equals, here comes the formula, sum product, and you can, once that appears, you can click on it, and you don't have to type the whole thing. And then it's going to tell us that we're looking for one or more arrays. So our first array is these cells, and then a comma, and then our next array is these cells. So we're saying take the value in, for example, cell C4, multiply it times E4, and then do that for each row, and then add them all together. And right now it's 0 because these are all 0. But you can see if I go in and put in 1 egg, it's going to give me 93 calories. Right? If I put in 10 eggs, I got 936 calories. Nobody wants to eat 10 eggs. So right now everything's on 0, and we're going to let the solver figure out a solution to this. I'm going to reset this because I was playing around with it before. So first thing we need to do is set the objective. The objective is going to be this difference cell, and we want to set it to 0. By changing the variable cells, it would be the portions. Okay. And I'm not going to put in any constraints now, just to show you how the solver by itself is not very smart, right? I am going to put in probably unnecessary, but I'm going to tell it I want a maximum time of 100 seconds. I'm going to say okay and solve, and it immediately comes back and says it wants me to eat nothing tomorrow except for 5.8 quarter pounders with cheese. Okay, that's not good. So the solver is sort of an artificial intelligence, except it's an artificial intelligence that hasn't been trained yet. You have to give it a set of rules to follow. So we're going to open it again. All of this stuff is still the same. My option is still set for 100 seconds. So now I just have to go in here where it says subject to the constraints, and I'm going to add some constraints. My first constraint is going to be that all of these things have to be integers. I'll say okay. We're going to need more constraints than that, but let's just see what happens now. It's come up with a solution. It wants me to eat 4 quarter pounders with cheese, 27 tablespoons of sour cream, and 3 slices of Texas toast. Yeah, that's still way not good, right? So I'm going to hit cancel. Let's go put in some more constraints. Whoops, wrong button. Wrong click. So again, all of my choices are still here. Double check this one, because if you've moved your cursor, sometimes that one changes and the output gets really weird. But we're going to leave it. So I'm going to add some more constraints, and I'm going to go through here, and I'm going to just let's do all of them. So bacon, less than or equal to 3 slices. And then I'm going to add another constraint. Scrambled eggs, less than or equal to 3 eggs. I'm going to add another one. Toast, less than or equal to 2 slices. I'm going to add another one. I want, for every slice of toast, I want a tablespoon of jelly. So I'm going to make this equal to the bread. Okay, I'm going to add another constraint. We're down to the quarter pounder with cheese, less than or equal to 1. I could say equal to 1. I got to have lunch. Yeah, I'm going to say equals to 1. I really like my quarter pounder with cheese for lunch. Not the most heart-healthy choice, but it'll survive. And then French fries, less than or equal to 1. I can do without them. And then diet soda, it really doesn't matter because it's 0 calories anyway. I can have all of it I want. I shouldn't have even put it in here probably. Blue cheese dressing. For the blue cheese dressing, I'm going to say I want it to be less than or equal to 2 times the number of cups of lettuce, right? So I want 1 or 2 tablespoons of blue cheese dressing. I also want it to be greater than or equal to, whoops, anyway. So blue cheese dressing, I want it to be greater than or equal to the number of cups. I don't want bare lettuce, right? I want at least a tablespoon of dressing and up to 2 tablespoons of dressing for each cup of lettuce. Okay, then I'm going to add another reference. And I like salad, but I can't really eat more than 2 cups of it. So I'm going to say less than or equal to 2 cups. Add another constraint. The steak, I'm going to say it's got to be 1 steak. I'm not going to eat 2 steaks for supper. And I got to have some meat. And then my baked potato can be less than or equal to 1, 2. let's say 1. And then my butter, I want it to be less than or equal to, actually no, I want it to be equal to. I want a tablespoon of butter on my baked potato. And then for my sour cream, I want it to be less than or equal to the number of baked potatoes. And then Texas toast, less than or equal to 2 slices. And lemon meringue pie, less than or equal to 1 slice. I'm not going to fill up on dessert. And then I'm going to say, okay, so here's all of these constraints. This is a lot. And notice a cell can have more than one constraint, right? It can be less than or equal to 3 and greater than or equal to 1. You have to put it in twice to get both of those. So let's solve it and see what we come up with. Wow, that was quick. Oh, that's not right. Hang on. Remember I said sometimes the solver changes things? No, that's still E24. I'm still setting it to 0. Subject to all these constraints. I don't know why that messed up. Oh. Lower and upper bounds on variables allow no feasible solution. Some upper bound on a variable cell is smaller than a lower bound, so I made a mistake. Let's see if we can figure out which one that is. I'm going to hit pause in the recording while I go figure this out. Okay, I found the problem. It says for cell C14, which is the baked potato, it has to be less than or equal to 1, but it also has to be equal to 2. We can't have both of those. What I really meant to say, let's delete the equal to 2. Whoops. So I deleted the equal to 2. I've got less than or equal to 1. Let's change that to less than or equal to 2. Say OK. And now let's see what happens when we run it. OK. You can see down here in the bottom left that it's running. We've got it set for a maximum of 100 seconds. Solver cannot find a point for which all constraints are satisfied. Oh, well, that's not good. Let's go take some out. Actually, let's just try deleting all of them. Let's start over. I got too happy with this, I guess. Or when you get really confused, you can always say reset all. Let's start over. So there's my objective. I want it to be 0 by changing these cells. And I want a constraint. I want all of these to be integers. And let's say I want all of them to be I don't know how that happened, but okay. I want to add a constraint. I'm going to say I don't want anything to be more than 3 servings. Then we'll solve it. Came up with a solution, but the solution has 2 slices of bacon, 2 tablespoons of jelly, even though I don't have any toast to put it on, 2 quarter pounders, 3 steaks, 2 slices of Texas toast. Not a great solution, but mathematically it's correct. So you can see, I'm not going to continue with this. You can see that if you spend some time adding constraints, And I tried to add a bunch at once. You're probably better to add them one at a time. But by playing around with the constraints, you can eventually get it to a solution that works. Like I said, it's like a really stupid artificial intelligence, and you have to spell out every rule for it. But the idea here is really not to come up with the perfect diet. The idea here is to learn how to use the solver. And this is the last thing we are going to do in Excel. So starting next week, we're going to start looking at programming using the R language. And that's it for now. We'll see you next week.